reason for the seasons.
Hey there, stargazers. I'm Dean Regas, astronomer from the Cincinnati Observatory.
And I'm James Albury, director of the Kika Silva Pla Planetarium in Gainesville, Florida. We're here to help you find your way around the sky tonight.
The winter solstice is Thursday, December 21st, and sun worshippers can finally rejoice. This is the time when the Northern Hemisphere experiences the shortest days and longest nights.
Wait a second. Rejoice on the shortest day? What's to celebrate? Sounds like lots of darkness.
Well, every day after December 21st, the sun will get higher in the sky and stay up longer above the horizon. The sun will stop its southward migration and start heading north again.
I wish it would hurry up already. It's freezing out here.
Let's show you the reason for the seasons.
The changing seasons are caused by one thing, the 23.5-degree tilt of the Earth. As our planet rotates daily on its axis, we also revolve around the sun. But our rotational axis is tilted compared to our orbit around the sun, and we always keep this slanted view.
When we, in the Northern Hemisphere, are tilted most directly toward the sun, we soak up solar energy to the max. That day is called the summer solstice, and it occurred on June 21st this year. At this point, the sun's rays shine most directly on the Northern Hemisphere. We get more energy per square inch, and thus it's hotter.
Now, the opposite occurs when the Earth swings around to the opposite side of the sun. Here, we in the Northern Hemisphere are tilted away from the sun. The sun's rays feebly strike us at a low angle, spreading out the same energy over a larger area. Each square inch gets a lot less energy than in summer. We call this the winter solstice, and that occurs on December 21st this year.
The sun's output is the same all year round, but the difference in our seasons is how much of that energy we soak up. It has nothing to do with how close or far we are from the sun. We're closest to the sun every year in January and farthest from the sun in July. So the distance doesn't cause the difference in the seasons. Hey James, you staying cool?
The sun is blasting off my hair.
Oh, you're doing great. Now let's see how our tilt affects the view from down on Earth. Oh, sorry about your hair.
It's okay, it'll grow back. Anyway, we have our skies set to December 21st, just before sunrise. Let's trace the path that the sun takes across the sky on this, the shortest day of the year. The sun will rise south of east and reach its highest point in the southern sky around noon. Then the sun will set south of west.
For most of the country, you'll get about 9 to 10 hours of daylight on this day. That also means you'll get 14 to 15 hours of darkness.
Let's compare this to the spring equinox. Next year, it'll be on March 20th. Now, let's trace the pathway that the sun takes on this day. The sun will rise due east, reach its highest point above the southern horizon, and then set due west.
Notice how the sun went higher in the sky than it did in December. The higher the sun, the more direct energy we get.
And look at how much longer the sun was in the sky. 12 hours of daylight and 12 hours of darkness. Equal day, equal night, and that's why we call it the equinox.
Now, what about the summer solstice? Now our sky is set to June 21st, and we can watch the sun rise north of east, go very high in the south, and set north of west.
The sun went higher still in the sky, and the hours of daylight reaching a whopping 14 to 15 hours for most of us in the U.S., with only 9 to 10 hours of darkness.
And all of this is caused by the 23.5-degree tilt of the Earth. So, on December 21st, watch this extreme southerly sunset.
And in 6 more months, it will reach the other extreme, northernmost sunset on the summer solstice on June 21st.
Soak up the solstice sun because the longer days are returning and summer is coming. Slowly. Keep looking up.